We're going on to number 15 in this video. Developing proof. Here's another way to prove the isosceles triangle theorem. Supply the missing parts. Begin with isosceles triangle HKJ with KH and KJ being congruent. Draw what? The bisector of base HJ. So if we have HJ and then the bisector would be this KM. So for A, it is KM. Given KH equals KJ, or congruent to, and they've already drawn those marks in. And then what bisects HJ? Well, that's KM again. And then we want to prove that angle H equals angle J. Angle H, angle J. We can't do that yet. So, C, KM bisects HJ. Well, that's given. That's part B right there. That's right here, given. HM equals JM. We can draw those in. We know that because that is what bisecting means. So that would be the definition of bisect. If KM bisects HJ, it cuts it into two equal parts. E, KM equals KM. Well, that is always reflexive. Something equals itself. F, triangle. So actually, after I draw that reflexive in, I have to actually draw it in, and I can see right away I have side, side, side. So that would be my congruency theorem to show that the two triangles are equal. And then I can say that the congruent parts, or corresponding parts, angle H and angle J, are congruent because of corresponding parts of congruent triangles are congruent. Find the values of x and y in each of these. Alright, so right away I see that this triangle is isosceles with these two sides being equal, meaning that this angle has to be equal to this angle. Well, if this one's 60, then this is also 60. And then all three angles, this angle and then these two, have to add up to be 180. So I say 60 plus 60 plus x equals 180. That's 120 plus x equals 180. Subtract 120, x equals 60. Oh wait, we should have known that already, because that is a, if it has side or angles that are 60, they are equilateral. Alright, going from there. If I know that this angle is 60, can I figure out this angle? Yeah, because they're a linear pair, or also known as corresponding angles. So they have to add up to be 180 degrees. So I'll just call this z right there. I know 60 plus z equals 180. Subtract 60. I'm going to get z equals 120. Now if this is 120 right there, I know if these two sides are equal, then this angle is equal to this angle, so these are both y. So if I had more room, I would work it out, but I know that 2y's plus 120 have to equal 180. Subtract 120, you get 60. Divided by 2, you get 30. So y is 30 degrees. 21. ABCD is a regular pentagon. So what I know is that all the angles have to add up to be, well, n minus 2 times 180. Well, n is the number of sides, so I have 5 minus 2 times 180. And that's going to be 540. And then that's the sum of all those angles. This angle, this angle, this angle, this angle, and this angle. So if I divide this by 5, I'll know what each of those are equal to. And I say that angle E, angle D, they're all equal to 108. So right here, I can say that's 108. Also, if this is a regular pentagon, each of the sides are equal, which makes this triangle AED an isosceles. Meaning that if this angle is y, then this angle is also y. So I say 108 plus 2y equals 180. And then subtract 108 and I get 2y equals 72. And then y equals 36. Now if this is 36, then this angle is also 36. And we know that all three of these angles have to add up to be 108. So I say 36 plus x plus 36 equals 108. Subtract 36 twice because there's two of them, and I get x equals 36. Moving on to 22. If I have an equilateral triangle, all of the angles have to add up to be, or I have to equal 60 degrees. So I know this whole thing is 60. So if this part is 30, then this part is also 30. And if this is an isosceles triangle, both of these angles right here have to add up, have to be equal. So therefore x is 30. And I know that 30 plus 30 plus y equals 180. So I say y equals 180 minus both 30s, and I get 120 degrees.